All right, for this problem here, we want to factor this quadratic equation. And to get started, we always want to first look for a GCF. No matter what, we want to see if we could pull out a greatest common factor. Because if we can do that, it's going to make whatever is remaining a little bit easier to factor. So first off, let's see, I've seen a 2 here, so I'm thinking maybe there's a GCF of a 2, but looks like I can't take a 2 out of this guy. So this is kind of making things a little bit difficult for me. So when I'm in this situation where I have an A value that's greater than 1 and I can't take out a GCF, this is a good time to go to our trusty box method. And so the way we set up this box is, well, we know two quantities or two sections of this box to start off with. I know my 2x squared, that comes from here, and I know my 6 that comes from here. The next thing I need to do is figure out what goes in these two diagonals. And the way that I do that is I'm going to have to find two numbers that multiply to the a times c, or in this case, 2 times 6 is 12. And I want to find two numbers that will add up to my b term, or in this case is 7. So I need two numbers that follow these conditions. So let's start by counting off some multiples or factor pairs of 12. We've got 1 and 12, 2 and 6, 3 and 4, and I think that'll do it. So let's see, I'm looking for a number that multiplies to a positive 12 and adds up to a positive 7. So it's looking like I'm going to have positive 3 and positive 4. So we've got a positive 3x here and a positive 4x here. Now it does not matter what the order is for, or rather which term goes in which box. Either way, it shakes out to be the same thing. So next, what we're going to do is we need to identify what the greatest common factor is of each row and each column of my box. Basically, we're reverse engineering this box. This is kind of like the area or the answer to a multiplication problem or an area problem with my length times my width. So we're trying to figure out how did we get here. So let's take the GCF of 2x squared and 3x. That's going to give me an x. And the GCF of 4x and 6, that's going to be a positive 2. Going this way here, I have a GCF of 2x. And this way I have a GCF of a positive 3. So this is going to give me my two factors. From the top, I get 2x plus 3. That comes from here. And over on the side, I have x plus 2. This is my fully factored form of my original quadratic equation. And remember, I could always check this by multiplying this back out by double distributing these two factors, and it should come out to be this original standard form expression.